Hi students, welcome to my channel. In previous video we discussed what are different types of rotations, single rotation, double rotation, and then when we will apply single rotation, when we apply double rotation. We have discussed in previous video. Now we are going to discuss example problems. So if you have not seen my video related to AVL, please watch those videos and see these examples. Okay, so now how to apply the rotations if the tree is not balanced. That is the point here we are going to discuss in this video. Okay, so now, so you know already single rotations and double rotations. Now I am giving you a simple trick when we have to apply single rotation. So in previous video we discussed theoretically, if tree is growing towards left outside, then single rotations. If tree is growing towards inside, then the double rotations are applied. Like that we have discussed. Now programmatically or logically, when can we apply the single rotation? Again, problematically or programmatically, so when can we apply this double rotation? Okay, this we are going with examples. Okay, so now for example, this is the tree 20 binary search tree. So here it is 10. For example, this is the tree actually. Now I want to insert an element 5 here. Okay, so this is binary search tree. You know how to insert an element, and first check whether it is an AVL tree or not. Yeah, for this balance factor is 0, for this balance factor is 1. It is an AVL tree. Now in this AVL tree we want to insert element 5. So this insertion operation is similar to binary search tree insertion operation. Again, if you have not seen this BST insertion, please go to my channel and watch this video, binary search tree insertion. So I will give the link here. Please click on that link also. Okay. So now how to insert this element 5? Compare with the root node 20 and 5. As 5 is less, then move on to left side. 10 and 5, as 5 is less, move on to left side. As there is no left child, then insert here. In this way, in a binary search tree, we will insert. Okay. Now, after insertion, is it an AVL tree or not? That we have to check. So, after insertion, it has to satisfy an AVL tree that the balance factor at each and every node is -1, 0 or +1. That we have to verify. Okay. So, for that, calculate the balance factors. Now, these are not the balance factors now. Okay. Now, I am writing here. So, balance factor at leaf node, here it is 0. Balance factor at this node is +1. Balance factor at this node is +2. That means here the property is failed. That means after insertion of element 5, the tree is not an AVL tree. After insertion, the tree is not an AVL tree. Now, how to apply or how to balance the AVL tree? For that purpose, so now we have to apply how to balance, you know. So, to balance the binary search tree, we have to apply rotations. Now, we have 4 rotations. Which rotation we have to apply? So here 4 rotations are there, na? So which rotation we have to apply? So what are those 4 rotations? Single left rotation, single right rotation, double left right rotation, double right left rotation. Now listen very carefully here. So which rotation we have to apply? So I am giving you a trick for a on left side. See here, the new node you have inserted on left side, na? The new node for So this is unbalanced node. Listen carefully. This is unbalanced node. For that unbalanced node, you have inserted that new node on left hand side. So on left hand side. So now if you have inserted on right side, if you understand these two cases, then it is easy to perform rotations. If you have inserted on left side, there are two possibilities. One is single left rotation and double right left rotation. Okay, if you have inserted on left hand side, then there are, so here totally 4 rotations. In those 4 rotations we are dividing into 2 sets. So here you are getting 2, here you are getting 2. Okay. So if you have inserted on left side, these are the 2 rotations. If you have inserted on right side, then the rotations are single right rotation and double left right rotation. Okay. So now see, again I am telling you, totally 4 rotations. These 4 rotations we have divided into 2. So 2 rotations and 2 rotations. So these two rotations if you have inserted on left side. So 2 rotations if you have inserted on right side. Now, so what are those 2 rotations? Here I have mentioned. Now, when we have to apply single left. Now, in these 2 rotations, when we have to apply this rotation, when we have to apply this rotation. Again, here also, when we have to apply this single right rotation, this double left right rotation. So now, there are one simple condition here. If you have generally on left hand side, when we will insert on left hand side, so the element is less. The element is less. Then we have to insert on left side. Okay. So if the element to be insert is less than, so some node where the property is failed, that node is there na. So PTR's left of data. If element is less than PTR's left of data, then apply single left rotation. Otherwise, that means in this condition is failed. If you have inserted on left side, okay, then these 2 rotations. In these 2 rotations, when we have to apply this single left rotation, when we have to apply this double right left rotation. So if this condition is satisfied, single left rotation. Otherwise, double right rotation. Now, on right hand side we have to apply these 2 rotations na. So then, when we have to apply single right, when we have to apply double left right rotation. Element is right side means it is greater number na. As you know, by this search tree, if it is less we will insert on left side, if it is greater then we will insert on right side. So element is greater than PTR of right of data. If this is satisfied, then apply single right rotation. Otherwise, apply double left right rotation. Okay. So element is less than PTR's left of data, apply single left rotation. Otherwise, apply double right left rotation. If element is greater than PTR's right of data, apply single right rotation. So otherwise, apply single left right rotation. If you have seen this example 20, 10, 5. Now see, based on these conditions, now 20, 15. Now we have inserted the element 5. Now which rotation we have to apply? Okay. So now this is the element what we have inserted. This is the element. Where the property is failed, this is PTR. PTR of left means this. Of data means 15. So you have inserted on left hand side. That means left hand side means this case you will get. This case you will get. Then in these two rotations, which rotation we have to apply? Element. That means 5 less than PTR's left of data. 20's left of data. 15. Yes, it is satisfied. Okay. So 5 less than 15. If it is satisfied, then which rotation we have to apply? Single left rotation. See, the single left rotation we have to mark like this. So then the tree you will get as, so tree is moving like this now. So then 15 will become the root node. Tree is moving like this. 15's right side 20, 15's left side 5. Okay. So now see, after rotation again check whether it is an AVL tree or not. So apply balance, find out balance factors 0, 0. For this also 0 minus 0, balance factor is 0. Okay. So like that, a single left rotation. Now similarly, for example, now I want to insert an element 18. Now for that, how can I do? For example, tree is like this, 20, 15. This is an AVL tree. Now I want to insert 18. Where we will insert 18? So 20 and 18 are compared. 18 is less. Move on to left side. 15 and 18 are compared. 18 is greater. So 18 you will get on right side. Okay. Now after insertion, so find out the balance factors. Balance factor for leaf node is 0. Balance factor for this 0 minus 1 equal to minus 1. Balance factor at node 20, 1, 2. So on left hand side, 2 minus 0, which is equal to 2. So that means here the property is failed. This is your PTR. Okay. So now for PTR you have inserted on left side. That means here these two rotations you will get. That means single left rotation or double right left rotation. So now which rotation you will get? So element 18. 18 less than PTR's left of data. Is that satisfied? Not satisfied. Then which rotation we have to apply? So then we have to apply double right left rotation. Then double right left rotation. So now in double right left rotation, what we have to apply here it is, first apply single right rotation at a child. Single right rotation at a child. After that at PTR apply single left rotation. That means, so 20 as it is, single right rotation at its child. That means here apply single right rotation. Then you will get the tree. Tree will move like this. So here it is 18, here it is 15. Then single left rotation at PTR. That means single left rotation at PTR. Here you have to apply single left rotation. 18, 15, 20. After rotation, apply balance factors. This is. So after insertion, the tree is balanced. So it is an AVL tree. Okay. So now another example. Now, for example, the tree is like this, 20, 30 is there. Now I want to insert element 40. Okay, where can I insert element 40? 20, 40 are compared, come to right side, greater it is. So 30, 40 are compared, 40 is greater, move on to right side. Now here you have to insert. You will get 40. Now, after insertion, find out balance factors. Balance factors here are, for leaf node it is 0, For 30, there is no left child now. So 0 minus 1, it is equal to minus 1. For 20, there is no subtree, 0 minus 2, which is equal to minus 2. At node 20, the property is filled. So now assume that node as PTR. Now, for PTR, you have inserted 40 on right side. Okay, that's why here on right side 2 rotations. On right side already I told you, on right side 2 rotations. What are they? Single right rotation and another one is double left right rotation. So when we will apply this, element is greater than PTR of right of data. Otherwise this one. That already I explained above. Now you can check it. So now this is PTR. So check this condition. As per this condition, what is element? Element is 40. 40 greater than PTR's right of data means this is PTR. PTR's right means 30. 40 greater than 30. 40 greater than 30. So this condition is satisfied. Then which rotation we have to apply? Single right rotation. Single right rotation at node PTR we have to apply. Okay. Now if we move like this, then 30 will become the root node. 30, here it is 20 and here it is 40. Okay. This is example 3. Now example 4. Of course after rotation it is an AVL tree. Now next example 20, 30, 25 I want to insert. Element 25. Where can I insert 25? 20, 25 are compared. 25 is greater. Move on to right side. 30 and 25 are compared. 25 is less. So here you will get 25. Okay. So now in these two rotations, this is the property. Find out balance factor 0. Here it is 1 minus 0 which is equal to 1. And here 0 minus 2 equal to minus 2. Okay. So this is PTR. The property is failed here na PTR. For PTR you have inserted and right side. Be careful. I am not checking for 30. For PTR we have inserted on right side. So on right side means these two rotations you have to apply. Okay. So these two rotations, check this condition. Element is 40, 25. 25 greater than PTR's right of data means 30. Is it satisfied? Not satisfied. That means which rotation you have to apply? Double left right rotation. So double left right rotation. Double left right rotation means what? At the child position, single left rotation, single right rotation at the node where the property is failed at PTR. Okay. So now for this node, 20 as it is, at child, 20 is a child, 30. Here which rotation you have to apply? Single left rotation. Move the tree like this, 20. Here you will get 25. Here you will get 30. And at node PTR, single right rotation. At node PTR. So 25, 20, 30. Of course, this is an AVL tree. So these are the 4 rotations you will get whenever you are performing an insertion operation. Okay. See what we have discussed in this video. So rotations example problems. Okay. So we have discussed 4 types and which rotation you have to apply under which case, that we have discussed. Okay. Hope you understand, students. Hope you understand, students. If you have any doubt, please send your question in the comment box. Don't forget. So if you have any doubt, so please post me and let me know which any other topics you want. You let me know in the comment box. Okay. If you understand the video, please share with your friends so that they can learn this AVL trees. Okay. Thank you, students. Have a great day. If you have not subscribed, please subscribe the channel. Bye. Thank you.